Hey everybody, let's try and do some Chapter 12 homework together. You can see that I have selected number 2 from Chapter 12. This should look pretty much, if not exactly, to the screen you see in my stat lab. I'm going to start out, my screen just went black. Alright, we're back. I'm going to start out by clicking here, opening up my sample data, click here, copy the table to the clipboard. Okay, done with the data. Now I'm going to open Excel to a new sheet and right-click my mouse. I'm going to simply paste my data. All right. Now you can see I've got some columns of data. Let's pretty this up a bit. We'll center those columns because I'm anal retentive and a little bit OCD, and we can center those row labels as well. This is a one-way ANOVA. One-way meaning there's only one way in which these groups differ, and that is these data belong to group 1, these to another group, these to yet another group, and these to another group. Apart from the group to which these data belong, there is no difference in the data, or that is to say how the data were generated. To perform an ANOVA, or analysis of variance test, I'm going to choose my data menu and then data analysis. If you do not see this data analysis tab or menu option up here, you will need to add it. Select data analysis and that box will open up, and there you can see ANOVA single factor, which means the same thing as one way for our purposes. Okay. Here is my data. It is grouped by columns, meaning each group of data is in a column as opposed to a row. Yes, I have labels in my first row, and I see here that I have made an error, that I actually only have data in D through G, so there, we've corrected that. When I make my output, I'm going to keep it on this page, so I'll click there, and this one always gets me. You've got to select there before you go clicking around, or you'll overwrite your data selection in the earlier box. I'm going to say put my data there in J3. That's where we'll put the upper left-hand corner. I click OK, and then through the miracles of science and ones and zeros, voila, my single factor ANOVA table is generated for me. So first, let's look at the summary table, and we'll practice doing some Excel formatting. Here you can see I have group 1, 2, 3, and 4 as was labeled in the data input. Here I can see the count. Here is the sum of the data. Here is the average. Here is a good opportunity to pretty up the data a bit. So I'll go back to my home menu, and I'll say let's make those look all the same. I just clicked there on that little comma button. Now they look the same, and they're easy to compare. If I wanted to make a bar chart or something, that would be easily done. I can now do the same thing for variance. I will highlight those 4, and I will click that button. Now they're all of the same format. As a casual observer, I will note that these 3 groups have relatively high variances as compared to the variance of group 4, which you can see is only a fraction the size of those variants. Don't know why, but that's how it is. Now, let's do the same formatting to that. We can take our F statistic and make it a little more easy to read. And let's take, we'll just leave our p-value as is, and our F critical value, we'll put a comma on that as well. Now, if you got really accustomed to looking at statistical output and making a decision on a hypothesis test, then you already know what to do with this. Let's write down over here our H0, that's our null hypothesis, is that mu1 equals mu2, which is equal to mu3, which is equal to mu4. My alternative hypothesis is that at least one of the level means, or the group means, is different, meaning they're not all the same. And I believe our alpha was 0.05. We'll check that real quick. Go back to my stat lab, and I think it was that one, and it says, oh, I was wrong. So use an alpha of 0.01. So we want to be highly confident in our result here. Okay, very easily done now. And I can look at my p-value and I can compare that to my alpha. Is my p-value less than my alpha? The answer is yes. And if you remember that I reject null hypothesis if p is less than alpha, so we can remember that. Also, I remember that I can reject my null hypothesis if my calculated statistic, in this case an f, exceeds my critical value. Notice here that my calculated f, which by the way is that divided by that if you have built these by hand, that calculated f statistic exceeds my critical value. So picture in your mind's eye a curve with a line drawn here for my critical value, and my calculated statistic is somewhere out here, well out into the rejection region. So I can reject the null hypothesis that my means are equal. Therefore, I must instead look to my alternative hypothesis and say, well, at least one of them is different. Now, we'll talk about which one is different in a minute or two, but for now we'll just agree that we will reject the notion or the hypothesis that they are the same. Let's go to our homework screen, and it asks us here to fill in the ANOVA table. So we can do that pretty easily. Here, 4 decimal places. Well, what do you know? They're already at that, so I can just, let's see, I think I can do this. Let's put those like that. There, 267.98 goes here, 267.98, and the degrees of freedom, 3 and 18, 3, 18, total degrees of freedom, 21. Uh-oh. Going to have to actually give ourselves 2 decimal places back there. 9808, 9808, and within groups is 152.8251 for a total, which is just the sum of those two, or that number, 420.8059. The mean square, that's what MS stands for, is 89.33, and my mean square error is 8.49. The F statistic is the ratio of the two, or 10.52, and my p-value is 0.000318, and we'll see if it liked our decimal place rounding there. And voila, something's not right. Let's see what it wrongs. It says at least one of them is incorrect. Well, look at that. It's our rounding. So shame on me for rounding too roundly. And let's see, 89 point, instead of 33, 89.3269 and 8.4903, an F statistic of 10.5211. Now we check. Uh-oh, still didn't like something. Oh, my p-value. It says I need another significant digit there. Fine, have it your way. And we'll make that a 77. Check answer, and it says, sorry, that's not correct. Well, that's just disappointing. Let's see if we actually missed something, or if it was just being a little particular as to our rounding. And we can see here that We were off by 1/10,000th there. Not too concerned about that. And so rounding error in my stat lab. Yes, I know it's ornery, and I would love to make it a little less ornery for you. Can't do that just yet. Anyway, that's correct to significant digits, despite the negative feedback here from the good folks at my stat lab. And that is a quick video lesson on how to perform that sort of analysis in Excel.